Solving Polynomial Equations in Quadratic Form, Part 2. Alright, here's one of these with the binomial. And because of the binomial, I need to set this up just a little bit differently. And that is we do what's called a u substitution. Because I don't want to have the binomial, I'm just going to say let u equal x minus 4. So when I do that, I end up with this nice, neat little quadratic look. U squared plus 5u plus 6, which you do know how to factor. That's going to have u's in the front. What multiplies to give me 6, it adds to give me 5 is this. Set each of those equal to 0 by the zero products property, and then solve them. On this case, I subtracted 3. On this case, I subtracted 2. But you are not finished. Be careful with this. All we have found out is what u equals. So we need to take those values and plug them back in for u and solve for x. So on the first time, I put negative 3 in for u equals x plus 4. Add 4 to both sides gives me 1. Same thing over here when I put negative 2 in for that u. I have x minus 4 equals negative 2. Add 4 to both sides gives me 2. And to check this, I would need to check both of them in the original equation. You don't ever want to check in the middle in case you made a mistake getting from the beginning to the middle. And if I put 1 in for each of these, it checks. If I put 2 in for each of these, it checks. You can check that on your own. Here's one that's not in the proper form just yet. Think about the first screen where it had everything on one side equal to 0. So it's the same rule we had before for factoring. We need everything on the left side equal to 0. So I'm going to subtract 13x squared from both sides and add 9 to both sides, which is going to give me this polynomial. It is the quadratic form because that middle power is half of the 4. But it's not the simple factoring anymore. It's not just x and x in the front. I need to get 4x to the 4th. So you might need to use your tic-tac-toe to factor this. Otherwise, you're just doing your plain old trial and error. I can put a 4x to the 4th here. My 9 is going to go here, and the negative 13x squared here. Now be careful right off the bat. To get this x to the 4th, I can't just go with x and x. This is going to have to be x squared and x squared. The most logical thing to get 4 is 2 times 2, but that doesn't work. I'm just going to tell you that to save a little time. So this is 4x squared, x squared. Looking back at the polynomial, the last sign was positive, the middle sign was negative, so I know both of these are negative. The most logical thing for 9 is 3 times 3, but it just doesn't work. The other product that gives me 9 is 1 times 9, and the way it goes is just like this. So multiply across is negative 4x squared, multiply across is negative 9x squared, which does go together and give me the negative 13, so I know I have this factored correctly. And remember on this, when you use tic-tac-toe, you group them on the diagonal. So it's 4x squared minus 9 with x squared minus 1. So we've got it factored out, but it's not factored completely. Hopefully you recognize that both of those are the difference of two squares. So this factors into 2x plus 3 times 2x minus 3, and this factors into x plus 1 times x minus 1. That means when I go to the zero products property, I actually have 4 little problems to solve, and they're easy to solve, just simple arithmetic. Subtract 3 from both sides, divide by 2 on that one. This one, add 3 to both sides, divide by 2. These are simple, just add or subtract 1 as the case may be, and there's our 4 solutions. Now, I'm big on checking. You may not be so big on checking. You may not want to check the fractions unless you could stow this in the calculator and type it in the way you see it, and then it's really easy to check. But if you have to check by hand, you may not want to do the fractions. I understand that, but at the very least, at least check with the whole numbers. I'd like to go over one more of these where you have to factor a little more extensively using tic-tac-toe. Here's our polynomial. It's got a coefficient of 3 in front of here. We do have a middle term of 1/3, so that when I set this up right here, this is going to have to be 3x to the 1/3 and x to the 1/3. Because 3 times 1 is the only way I'm going to multiply to get 3. The last sign is negative, which means these signs are different. So a minus and a plus. Best choice for 4 would be 2 times 2, but it just doesn't work. But what does work is 4 times 1. Multiply across is negative 12x to the 1/3. And the bottom multiplication is positive 1x to the 1/3, which when I put that together, I do get negative 11x to the 1/3, which says I have factored this correctly. Looking at this along the diagonal, and we have 3x to the 1/3 plus 1 and x to the 1/3 minus 4. Using zero products property, we have these two equations. Working on the one on the left, subtract 1 from both sides, divide both sides by 3, and you have x to the 1/3 equals negative 1/3. What I have been doing on these is changing this rational exponent to a radical, but you really don't have to. You can think about raising this to the reciprocal power on both sides, and that will undo this 1/3, because if you raise this to the third power, which is the reciprocal of 1/3, raising a power to a power, you multiply the exponents. So 1/3 times 3 just gives me x to the first, or plain old x. Over here, same thing, raise it to the third power, multiply this out, and you get negative 1/27. If you are letting your calculator do this arithmetic for you, be sure you put that negative 1/3 in parentheses before you raise it to the third power. Same idea over here, x to the 1/3. To undo that rational exponent, just raise it to the reciprocal power, which is still 3. So 3 times 1/3 gives me x to the first, or just x. 4 cubed is 64. So our two solutions are x equals 64 and x equals negative 1/27.